4 ones and 5 ones is 9. I don't have to count them, but I am looking at my tiles. So I have 6 10s and 1 10. I know that I have 7 10s. I have 200s and 300s. I have 500s. So you are seeing this, but the kids are not. This last one about, and I'll get off my soapbox. The kids are not looking at this and completing the problem here. They're completing it off of their work. Let's do another one. Could you go ahead and build this one? Oh, you can't see. Okay, then I have to think about what you keep. Here we go. Nope. Here we go. Class, your kids would have done a lot of those first ones. I'm now taking it to a next level. So we're going to go back. We're going to look at what we've built. I have 4, 5, 6, 7, 8, 9, 10. Your kids know very well that when we have a 10, we're going to make it into a 10 and put it here. That's enough. So how many do I have left? I have 2 1s, and I moved a 10 over to the 10s column. Originally, we had 12 here. It is much easier for kids to see that 12 written there instead of in the old days we would have carried the one over the top. Simply moving it down to the bottom, it also mirrors exactly what I did. I took 10, I made it into 1, and I moved it over to the 10s column. I don't think we would really carry all those there. How many do I have now? I have 1 10, 2 10s, 3 10s, 4 10s, 5 10s, 6 10s, 7 10s. I have 8 10s. And how many hundreds do I have? 5. So I'm note-taking about my actions. We really need to make sure they understand what's going on there.
What did you reference say when we got that tool?
But remember, they're not particularly looking at this. They are looking here. How many do they have? They have 2. Yeah. Yep, the answer is coming from this sheet. The answer is coming because they built it.
Okay, so you just take all the ones, if it makes 10, like
Yes.
what we did here. So, and we carry it forward to the 10 section.
We make a 10 out of it.
That's right.
And
then
put the
you
10
add
here.
all the 10s, including the ones that you have made.
Sure, because it's there.
Yes, and, okay, cool.
Yeah.
That's all.
Yeah, it's like, oh, that's what we were doing, but just on paper. But here it is, and I now have it.
And what's the reason for doing the carry down at the bottom, not this?
Originally, how many ones did we have? If we counted them out, we had 12.
12.
For visual kids, they can actually see a 12. It is 1 10 and 2 1s, but they can visually see the 12. That will make a difference to some kids.
They can look anyway to find that, or no?
No, we're building it. They are using this to find the answer. Yes?
When they're using this method, how are they at home for homework? How are they supposed to show their work?
They know it.
the very next thing I'm showing you is the representation. So we won't be sending them home with tiles. And to be fair, tiles can get very cumbersome for some kids, or they knock it and it flies off the table. They need to do it to understand what these dots are representing, but we really do move to the representational, which is the next.
Excuse me, will you go the subtraction part?
Yeah. Let's figure out how to represent it, and then I'll show you that in 4 minutes. So the representation, honestly, is very obvious. It's a little bit of a root word. We just draw it. We put hundreds, tens, ones. We draw our number. I write my notation so I can keep track of what's going on. I have 7 ones, I have 7 tens, and I have 3 hundreds. And it always goes back to asking the child, what did you draw? Would you go ahead and try 505 plus 75 yourself? Oh, yeah. Right. It's the same, except we just went into labor because now we get. Yep. But we want them to recognize the height, because what this is the because these are, when you look at them, they're all equal. So you have to think of 7 tens. So it's that idea of recognizing. Yes, thank you. And I'm sorry, I looked at the clock and I should have done this one with you also. What happens? Oh, this will be down here. But you would circle it and you would draw it and draw the 1. Yes?
How is this different from addition as we were doing it before, rather than just a visual doing addition? You know what I mean?
How is this different?
So this is, if we were just doing the maths or just the numbers, we'd be able to see, like, put 1 across, even if we added the 1.
I guarantee that you as an adult see that. As a child, that algorithm is not, it's a 1. We can talk them through it, and they are going to naturally start seeing that. But we want to make sure that they can see it and understand it and explain it. And
But
that
it's just
1 is a 1.
representing
Oh, yeah.
that, so-
By the time you see the subtraction, yes, it does look exactly like it. But we want them visualizing it and understanding that that's 110 that I moved over, not a 1 in the second column. So a lot of the language that we're asking their kids to explain with this, they would be using place value language. I made 10 ones into 110. 10 ones equals 110. So it's really taking the algorithm and exaggerating each and every point so that they understand it. I'm looking at the clock and to honor time. Does this make sense? Okay, I want to look at the subtraction. It's the next page. Now in this case, in subtraction, you don't write down the second number because it's being taken away. So we demonstrate 238. I need to take away 27. I'm going to take away by putting a line through it. So what have I done? need to take away. Now, here's where your child might have gone back to number bonds. Took away 7. I'm going to take away 2 10s. I have 1 10 left. I'm not taking away any hundreds, so I have 200. And everybody, where did I get the answer from? From the picture. This is my note taking. So what happens when we get to the most complicated ones where we have to start regrouping? We draw it or build it. At this point, your kids are going to learn a strategy of looking at every single place value first before they start finding the answer. So they're going to look, can I take away 6 1s from the 2 1s that I have? No, I'm going to be able to, I need to make a change. So I'm going to take this 10, I literally draw an arrow and draw in the 10 1s. I have marked this differently than when I took it away for the subtraction. When I start trading, sorry, that's not perfect. I put a slash mark through it. Your teachers are probably going to be pretty particular about that notation. Now I'm going to ask, can I take 5 10s away from the 5 10s that I have? Okay, so I don't need to worry about that. Can I take 300s away from the 800s? For me, that was a little bit different. I'm used to solving one column and then looking at the next. Your kids will be looking at each of the place values to get the problem set, then do the subtraction. So now I can take away my 6. Does it matter whether I take away this 6 or the other? No. I still get 6. I'm sorry. When we did this, we should have made our changes up here. I no longer have 7. I have 6, and I have 12 1s. That was to be done as I did the action. Kind of the point of the lesson. So now I have 6. I have 5. I have 6 10s minus 5 10s. I'm going to take away 5 of them. I have 1 10 left. I have 800s. I'm going to take away 300s, and I have 500 left.
Excuse me, this is regroup.
Yes, I did regroup. That's exactly what that action was. That's what it's called. It's called regrouping, and I demonstrated the action here. Yes? The only time they're going to say use this strategy is because they want them to practice it and get comfortable with it. By the time the assessment comes, they will not be told which strategy. It is up to them. However, if we don't practice the certain strategies, and especially if kids think they know another one that they like better, to give that other strategy a fair chance, we will make them practice it. We are not going to make kids who can explain this to me keep drawing it out every single time. There will be a point where they need to do it. It will also help their language and their explanation. So, but by time comes. And a lot of your kids just took a pre-assessment where they were given a problem. Can you see that? It was a little interesting to see how many of the kids wrote this. They learned an algorithm that meant nothing to them. When the child can show me this, I know they're understanding it. Just because they can do this, I'm not always sure. So yes, we do want them to move on to more efficient. We don't want them to get stuck, but we do want to make sure they understand.
She's really very good with what she's saying. She's very confident. With the little more big moving, she's very confident. I'm not sure how she's gonna.
She needs to be told that's what good mathematicians do. Good mathematicians do not rely on one strategy, and they have to be able to respond to knowledge. That's what makes a critical thinker, and that's the skills we need. Getting just the right answer one way is not what makes people successful anymore. It used to work, but now we've got computers to do that. So, yeah, I mean, should she have to do hundreds of these problems? No. Should she have to do some? Yes. Okay, it is several minutes past. Please, I know it's my soapbox. It's about the drawing and the building, and this is about the notation. If we skip too quickly to that notation, and they don't have a way to back it up and think about it, we're doing them a disservice. However, we are getting there. As they understand it, you've got bright kids. They're going to start seeing, but wait a minute. Every time I did that, this happened. That's what we want. We want our kids thinking. Yes?
So next time that I'm trying to do is when people say, when you're going to take some of the 642 minus 663, I need to borrow from my husband's card.
Yes, you do.
So now, am I going to put 100 with drugs in here, or how am I going to?
No. You are in place values.
Okay.
Each one of these are worth 10. So
Right.
your 100 is 10
I'm going to
tens.
take 10 away from these.
Does anybody mind if we do this one? So you have, can you see me? Where am I? 642. Okay, first of all, I know that I need to change I need a 10 to be regrouped into ones. Now, this time I'm going to do it properly. I'm going to make that notation immediately. So now I have 3 10s and I have 12 ones. Now I'm looking, I need 4 10s and I'm going to take away 6 10s, and I really have 3 10s, so I have to take away 100 and make it into 10 10s. And I need to write that down that I changed this into 5. How many do I have? I have 13 10s. So now, can I do it? Let me see. I can take get to my right problem. I can take 3 1s away, and I have 1, 2, 3, 4, 5, 6, 7, 8, 9. I can take 6 10s away, and I have 1, 2, 3, 4, 5, 6, 7. And I can take 2 100s away, and I have 3. Now within this, we've got kids thinking about their number bonds and breaking numbers apart. They might be asked to show that you can see how the arrow way probably doesn't blend with this one as much. But we go back and forth which strategy is going to help us the best for the particular problem.
Is there any better way to draw the dots so that they can be also, for example, like on one line, like so you put 2 and then 1 bottom.
I think that becomes real personal. The more visual the child is, they might want to make their dots like in rows of 5, because we use 5 trains all the time. Space becomes an issue. And that's one of the things we start learning about. We get the same answer no matter what. If the child needs that, yes, get them a bigger piece of paper and have them draw it the way that makes them feel comfortable. Hopefully that's one of those fluidity things that they can be comfortable seeing 10 as 3, 3, 3, and 1. If they need to see it 5 and 5 to begin with, then that's what they need. That's really going to be probably dependent upon the child. Now, I'm saying all of this, and we zipped through a 5-week unit in 45 minutes. There are going to be baby steps along the way where your teachers do require certain things. I think they start off by writing in the numbers on these circles. I don't know how necessary that is, but I hate to say it, if your teacher asks for that at the beginning to make sure they're understanding it, it's important that they do it. Yeah. This is the very beginning. This would be the first way they would see it. And yeah, they're going to start noticing the pattern. Not in grade 2. By grade 2, the standard specifically says they are able to add and subtract to 1,000 using models and representation and place value strategies. Grade 3, they will be using it. There'll be representations of skip counting and group sub, but it's not multiplication facts or anything like that.
My big question is, are they going to memorize them?
Not in the second. By the end of 3rd grade, they are supposed to have their multiplication facts memorized. End of 3rd.
Right.
After they figured out what is going on, after they practiced it.
There is no strategies like this now, some demonstration, or there will be strategies on habits.
Yes,
Because memorizing is one thing.
memorizing comes at the end of understanding.
Okay.
Comes after understanding it, practicing and using it. Yes, they have to know it by the end of 3rd grade. Thank you very much. There are yellow or blue. Are they all yellow? Feedback forms. We would love to know what went well and what could be improved. Thank you. That's great. And we'll let you know about the trailer of whether this worked or not. Ruben, turn it off.